So I'm going to enter bad data, Joe. It says invalid input. 100. Yay, number is 100. So it exited the loop and it did whatever we wanted to do down here. You know, we could do some kind of calculation based on that input. So I'm going to draw this. We already know how to draw while loops. I'm not going to ask you to draw this one along with me. If you feel like it, you could. No letting your mind wander off and checking Snapchat just because I didn't ask you to draw it with me. Alright, so we're going to start it with a start. Then we're going to set our flag equal to false. That's a math statement more than anything else, so we're going to put it in a process block. Valid is equal to false. Now we have a while loop, so we need a decision block. While not valid. And in this language, I keep forgetting false and true are capitalized, so although we don't strictly have to follow those dictates when we're doing flowcharts because it's not the actual syntax, I'd rather do that so that I wouldn't get frustrated later when I was trying to type it in. Okay. Let's put the source code for this over here so we can keep going. What's the first thing inside our while loop? We have a print statement here, so I'm going to put that print statement here. What does a print go in? What kind of shape? Yeah, trapezoid, or whatever we've been calling it. Data block. So print, please enter a number. Then we're going to use the input statement, which comes in the same shape because it's also data. It's also input output. So number is equal to input. Now we have an if statement. We're going to check to see if it's composed entirely of digits. If I want to use this specific syntax, I could. If number dot is digit, like that. Or I could word it more generally, like if. That should have been if, not is. The syntax looks kind of nasty, but we're going to go with it. If it is, then great news. Good news, everybody. Alrighty. We're going to convert it to an int. That's just math. And then we're going to set that flag equal to true. So number is equal to int number. Then set that flag equal to true. Another math statement. That will exit us from the loop eventually. And I know I'm going to need a circle to hook these lines back up, so I'm just going to make that right now. Alright, on the false side, what do? If it's not good data, we just print an error message, invalid input. So on the no, come over here, print invalid input. That's in the wrong place. That's the while loop. Excuse me. that should go down here. And then it needs to hook back up. We're done with our if statement. Now I'm going to zoom out again because this is getting harder to see. I haven't been trying my best to keep everything compressed. And I need this to go back up to the while statement in some fashion or the other. Usually I try to make it go like that. However, that means the rest of this stuff has really got to move a little bit. All right. That's our while loop. Well, this looks kind of interesting. I don't know what's going on there. Get over there. All right. And then lastly, we have our print, yay, number is. So that's on the false side, the no side of the while. We are done with stuff. So we're just going to print a message, yay, number is, comma, and then the number we're printing. And then we're done. Print our stop. Or not print our stop, but put our terminator there. Okay. May not be the prettiest loop, but hopefully you can see that that's the same thing as the code.
I have a question.
Mm-hmm.
How do you make it to where if they input a number not in the range that it will give them an error? 'Cause
Well,
you type in 101 and it will say yay.
right. So we would need to do a little bit more checking down here before we say it's valid. The only time it's really valid is if it's between, you're right, because I forgot to put that here. Enter a number between 1 and 100. So I should change that. Between 1 and 100. But it's not valid data until we know that it's within that range. So instead of just saying valid is equal to true, as soon as we convert it, we're going to put an if statement there. If number is greater than or equal to 1 and number is less than or equal to 100, then it's good data. Else it's not good data. Does that make sense? We just piled another condition before we set that valid is equal to true, and we could put as many conditions on it as we wanted to. And strictly speaking, for me to be happy with my flowchart, I'd like a little circle down here for these two if statements to hook back up to, and then make that one come over here. But I'm not going to mess with that because it's getting pretty ugly already. Now we pretty much know when we're coding that if there is code on the no side of an if statement, we have to use the else keyword. But if there's no code on the no side of an if statement, if it just falls straight down, there's no else involved. People get into the habit of thinking there's always got to be an else. And so they start trying to shoehorn else's in where they don't need to happen. And in this particular case, this is just an if, then. But if this isn't true, we don't need to do anything. We could print an error message. That would be the right thing to do, is to also print an invalid input. And this is getting so messy that there's probably a cleaner way of implementing this.
You could put the no over to the print invalid input.
Yeah, we could save this invalid input and put another if valid is equal to false down here and print this message if the input is equal to valid. Or we could, what were you suggesting again? It sounded right.
Instead of having just go down to the next line, you just have it go over to the print invalid input.
That would be good, except you can't do that. And if you think about it, the reason why, I'm going to go back over here and code what the change we just made. Where it says right before if valid is equal to true, I'm going to do if number is greater than or equal to 100 and number is less than, greater than or equal to 1 and number is less than or equal to 100. I don't need the parentheses. There we go. Now, on a chart, yeah, sure, I could drag a line over there. But when I was coding it, there's no way to do that. There's no way to get two things to go to this print statement. Yeah, strip the else off and make that an if statement instead. If not valid. There we go. Now we've completely gotten rid of all of our else's. And we should revise our flowchart to match.
Mr. Thompson?
Yes, sir.
How would you write, like, if you had an if statement that had, like, 3 conditions, how would you do that?
You can keep chaining if statements with ands if you wanted to. Like if you wanted to see if the number is even, enter an even number between 2 and 100. If number is greater than or equal to 2 and number is less than or equal to 100 and number modulus 2 is equal to 0, see now we've made it three conditions.
And, like, because, like, I was working on something, it was kind of like a guess a number type thing, and then I wanted it to make it print, like I did a if number is less than guess, say, or print your number's too low.
Right.
But how would you, like, I couldn't get it to do all the other two.
Okay, very, very good one. And in fact, a guessing game is an excellent thing for us to implement at this point because we're doing that kind of thing here already. We're checking to see. What you're asking is, if you wanted to make a game, pick a number between 1 and 100. I have a secret number in my mind. And then you type in 40. I should tell you whether it's too low or too high or whether you got it. So we would need something kind of like this. I'm not really fond of this text, which is why we're not using it, but there is this alternate text, head first programming, a PDF. We're going to download that. And it's got a guessing game assignment tutorial built into it. So here's their first attempt at it. Print welcome. And then G is equal to input, guess the number. And then we convert that to an integer. If the guess is equal to 5, apparently that's our secret number, print you win. Else, print you lose. Game over. All right, now, yeah, that's pretty harsh. We only get one chance at it.
It doesn't even say what number between what and what.
Right. This is a lousy first effort. So we're going to keep looking.
Because, like, I was working on it and I couldn't get it to print the other, like, saying if it was too low or too high.
That's, you use elif. E-L-I-F stands for else if. That's what you would need to do. So we want to modify the program so that if they type in a 3, it'll print too low. If they type in a 5, you print too high. And if they type in something larger than 5, it'll print, it'll print you win. Otherwise, it'll print too high. So let's modify this a little bit. Make a new one called secret. This is going to be our guessing game. Or we could call it guess. Save as, call it guess.py. Now we're going to take it a little bit further than they did because I know in advance where they're going with this. We're going to set our secret number equal to 5. Then we're going to do print, enter a guess. And this is still pretty lame. We're not telling them, they could guess 8 million because we're not giving them limits. And so we're going to say guess is equal to input, and then guess is equal to int guess. Convert that to a number. Now we're going to check. Is the guess correct? Is guess equal to secret? Print, you win. Elif, colon, wait, no, that's not right. Elif space guess is less than secret. Print, guess too low. And then finally, an else. Print, too high.
So you couldn't do like another, else if guess is greater than secret, or?
You could. Most languages do this, else if. This language just happens to have elif as their keyword. But you could do this as well. Y'all don't type this. This is an alternate one showing you that you are correct. You could do it another way. You could do this. If guess is equal to secret, print, you win. Like I said, don't type this. Else colon, and then underneath that, if guess is less than secret, colon, print, too low. And then back here, else, print, too high. Both of these work. Whether you like one way or the other is up to you. This way is actually more similar to how you'll see it in other programming languages like C, C++, Java, JavaScript, except it would have that word instead, else if. Kind of too bad that this language doesn't support else if. Let's see if it does. Yeah, we're getting an invalid syntax right there. Why would you pick one over the other? Well, this is actually simpler in as much as we have what's known as a nested if here. Meaning that we have stuff that's getting tabbed over two instead of just one. So the logic is a little bit more complex. Not really, not functionally. But if you have an if statement that's enclosed in the body of another if statement, that's considered a nested if. This has a nested if, this does not. So I recommend going ahead and using elif rather than just using else colon and then hiding another if statement inside it.
And the difference between else if and else is?
Well, elif means that this condition has to be true before it would do that.
Okay.
But if that was just else, it would do that no matter what.
Okay.
Yeah. All right. So, what would make this game better? Couple of things. One is we need to keep looping until they get it right. Another is if the secret number is randomly generated rather than being the same every time. And then the third, I lost my train of thought. We tell them the range. So like we're going to make a random number between 1 and 100. And then generate. We're going to tell them that it's between 1 and 100, and then we're going to keep looping until they get it right. So what this author is doing is they're doing road maps rather than flow charts. Is guess equal to 5? Yes, it is. Print you win. No, it's not. Print you lose. Well, a flow chart is really, conceptually, this is okay. But we want to get to the point where we're saying either too high or too low. And here the author is illustrating using, instead of an elif, just using an else, and then doing another if statement. So is if guess equal to 5, print you win. Else, if guess greater than 5, then print too high. Else, print too low. So that's how the author did it, which is the way you were suggesting. You use your else, and then inside it you nest another if statement. That matches his roadmap. All right. Why do I have to keep rerunning the program? I only get one guess. The users still don't like it. So the program needs to be able to run some code repeatedly. We're going to use a loop. Wouldn't it be dreamy if there were a way to get a piece of code to run several times? But I guess that's just a fantasy. No. There's a while statement. Yeah, you can see that this textbook is kind of silly. Alrighty.
It's like for basic beginners.
Well, you'd think. But then it immediately leaps into reading strings off the internet and doing string manipulation on them. That's like all chapter 2 or something. So it's not structured as its main problem. It's written kind of childishly, but yet it covers advanced topics. So some people like it. No, absolutely nothing wrong with stepping through it and learning a lot from it. Okay. He didn't add the while loop here, but he did get the ability to generate a random number. So let's go ahead and add this to our code. Up at the top, we're going to add an import statement.
And remove secret.
Well, we're going to keep secret, but we're going to make it a random number instead. So up at the top, we're going to do from random import randint. Previously, we were importing an entire library. We just did import turtle. This is illustrating just bringing in a single function from a library. So from the random library, I just want this one function. Is there a reason to do it that way? Nah, not really.
Put import twice.
Whoops, you're right. From random, change that first word to from, import rand, and then do secret is equal to randint, and we want a random number between 1 and 100. A little bit more interesting than 1 to 10. Then I need to get rid of that secret is equal to 5. All right, I'm going to make sure this works without a syntax error. There's no reason to add 20 lines of code and then have to debug 10 of them. Okay, so enter a guess. 100. Too high. Okay, so whatever the random number is, that was too high. But at least I didn't get a syntax error.
That'd take forever.
And now we're tacking on the while loop. What is our while condition going to be? This is dumb because it doesn't use the keyword secret like the other one did. But ours will. So I want to do this over and over and over. What is my while condition going to be? I want to keep looping as long as what is true. as long as our guess is not equal to the secret. That means we're going to have to declare, and you kept asking why we didn't declare things. We're going to declare our guess variable first. We're going to declare it to something that's completely invalid, just to make sure that our while loop is true. So I put the line above the while loop, guess is equal to -1, and then we're going to keep repeating while guess not equal to secret. And then we have to tab all of that stuff over. What I did to tab all of it is I used the shift up arrow or the shift down arrow to highlight it all, and then I hit the tab key. Or if you like menu options, there's indent region, and then there's format dedent. All right, so then we're going to print a you win.
Why is there an exclamation point?
That means not.
This means not equal to. I could rewrite this as while not guess equals secret. Those mean the same thing, but I'm going to change it back to the way it was. This means the same thing as in junior high or grade school or whatever, that meant not equal. All right, I'm going to run it and see if I have syntax errors. Enter a guess. 50. Nope, that's too low. 75. That's too high. 62. Too low. Okay. 70. Too low. Now your number is going to be different. 72. 73. 74. You win. Okay. So this is what's known as a binary search, actually. We keep using that word binary. It just means, in this case, again, 2. You pick the halfway point between the smallest number and the largest number. It's the most efficient way to do it. And in this case, 50 was too low. So I chose a halfway point between 75 and 100. So I could, again, eliminate half of it so that there were only 2 choices. And that was, again, too low. So I chose a halfway point between 75 was too high, so that eliminated, that half. And now we know it's between 50 and 75. So I split that again and made it 62. And eventually it turned out that, I was real close when I did 75. And I did all these guesses just to find out it was 74. But a binary search is the easiest way of winnowing out a random choice like that. You could just start at 1 and go all the way up to 100. But this is a more efficient way to get you the better guess. Alrighty.
And I don't think we need another print you win statement.
You're right. We don't need this one because we already had it up here.
Okay, what I'm confused about is if you want to, say they don't want to play anymore.
You want to let them quit?
Yeah, I try to do that, but every time I do it, it would because I would use the exit thing, and then it would just wipe it.
Yeah. That's where that break statement that I kind of brushed up upon and then backed away from would be good. Let's go ahead and, I'm going to demonstrate it, but I'm not going to ask you all to type this because I'm going to take this logic in a slightly different direction. Enter a guess or cue to quit. Here's what I would do. After I got my input, I would do if guess is equal to cue, then break. That exits the while loop. I certainly would not want to print you win at that point, but I've commented that out anyways because we already printed you win up here. That'd be one way to do it. If you put an exit, it bails the program completely, but if you put a break, it just exits the while loop.
Okay, so you could put that at the end and say press Q to quit, and then set Q equals break. Okay.
All right, I'm interested in how many guesses it took. I'm going to take this break statement back out. I want to create a counter and then add one to it each time we guess so that we can print out the number of guesses. So I'm just going to make a counter. Counter is equal to 0. And the first thing we do inside our while loop is counter plus equal 1. We add 1 to our counter. And then down here at the bottom, we're going to say how many guesses it took. Print total guesses, colon, comma, counter. Sorry, let me. Too high. 25, still too high. 12, too low. Oh, give me a break. Okay, anyways. There. It took me 10 guesses. I didn't quite do that binary algorithm correctly, that having it. I accidentally at one point typed in 27 rather than 17. And then I got lazy and just started doing 20, 21, 22, 23, 24 rather than trying to keep dividing it by 2. The only thing left to do would be to tell them the range. We have a range of 1 to 100 up here, but we're not telling them that. So I think I'll tack that on, or I'll put a print statement. Print, I'm thinking of a number between 1 and 100. All right, now would be a good time for me to walk around because I've made so many changes to the middle of it that some people. Okay, and you had asked for a review of flowcharting. Here's the PowerPoint that I hope explains it. This is just a logic for an if without an else. If something, do something. There is no else because if the condition is false, the no is just to go straight down. Here's an if else. If, and if this is true, then come over here and do something. Else, do something else. Now, if you wanted to make your flowchart look exactly like this, you could delete that word no. That happens when we make more than one line off a decision block and change it to else. That's cool. I kind of like doing that, but I haven't been doing that yet when I demonstrate these to y'all. And here's an if else, elif else. And it's more complicated, unfortunately. If this condition is true, do something. And then we have a line going all the way down to the circle. If that's not true, then down here, elif, and we have another condition there. If that's true, then we come here and do something. And we go down to the circle. And if that's not true, then we go and we do something else. Another way of doing it is just to put the else condition right there underneath it. This is the same logic. It's just that this else block moved down there. So back to our flowchart. That section of our code is going to look something like this. If guess is equal to secret, then print you win. If that's not true, we're going to do an elif underneath there. Elif guess is less than the secret number. Then we're going to print what? I mean, obviously we're gonna print too low. But if that's not true, then we need to print too high. And so I could leave that word no, or I could make it no/else, or I could just make it the word else. I'm just going to make it the word else. And I guarantee that the next time I ask you all to do this, somebody's going to put the word else inside of a decision block. Don't put an else inside a decision block. The reason is because it's not a function, it's not a key, it's not, a process, it's not a decision, it's just a direction, it's just a line. And if that's true, then we print too low. Then all this stuff needs to hook back up at a circle at the bottom. And you can frustrate yourself for hours trying to get all these lines. There we go. So really I'm going to need a line coming into the top of this, which I didn't have. I'm just sticking this up here temporarily so that I can have a line. There. There would be something up above, and then there would be something below. But that's how you flowchart an if-elif. It's kind of ugly. Flowcharting was invented before programming languages, so sometimes what looks clean in code doesn't look clean when you flowchart it. And I really can't think of a better way to do it. I can't hook this line up to this, because that would make it look like you print you win and then you print too low. So it really does need to jut off like that. Conceivably, I guess I could make this line go off to the side like that. And like I said, you can spend hours doing this. Oh, that's funky. Like that. That makes it look a little better. Not much. Alright. That's enough obsessive compulsing over it. Alright. That'll be inside the while loop. So I've already kind of given you almost half of the flowchart there. That's okay. The first time you do something, it's okay to hold your hand and show you. So let's go back to our code and turn that in as an in-class assignment. So I'm going to go back to my guest code. I'm going to put a comment up here. You should put your name up here. Guessing game. But then the homework will be flowchart this. And one way to teach programming is to not teach the programming first, it's just to teach the flowcharting. And if you do that, then your flowcharts are not as detailed as ours are. We're pretty much putting a block on our flowchart for every single line of code. But it could be simplified to some degree. I'm not going to do that. If you're making a flowchart without having the code in front of you, which is your normal way of doing it, you may not make it as detailed. You may just put something like enter guess rather than guess is equal to input, guess is equal to int guess, because that stuff is Python specific and another language would read the number in a different fashion.